The universe is so big and so old, so where is everybody? That question is the Fermi Paradox. It's a contradiction that's been with us for a long time. The numbers say space should be full of life, but we look out and we hear nothing, just silence. So we're going to look at 25 answers, scientific answers. They challenge logic, they challenge reality. One idea is that we're in a cosmic zoo. Another is that every other civilization is hiding. Or maybe our universe is a simulation. Each answer makes us rethink intelligence. It makes us rethink where humanity is going. So what do you think is the most likely reason for the great silence? Enrico Fermi asked a question back in 1950. It was during lunch, and it's a simple question, really, but it's stuck with us. The galaxy has hundreds of billions of stars. Many of those stars probably have planets, so the numbers, the probability, it feels overwhelming. Life should have come up, intelligent life. It should have happened over and over, given how old the universe is. The math seems to say that. Frank Drake later put it into an equation, the Drake equation. It's not one answer, it's a way to think. You multiply the factors. The rate stars form. How many of those stars have planets? How many planets could support life? Then, how often life actually starts? How often that life becomes intelligent? Technological, and then how long that civilization might last, sending out signals we could hear. If you use optimistic numbers, the galaxy should be full. It should be talking, a cosmic metropolis, but when we listen, when we point our best instruments at the sky, we don't hear a cacophony, we hear quiet. A profound quiet, that's the great silence. It's the gap between what we expect and what we see, between a universe that seems built for life and one that feels empty. That silence is the canvas. Every theory, every idea we have is painted on it. They're all just trying to explain the quiet, to answer why a cosmos so full of potential feels to us so alone. That quiet out there, it's not just a puzzle, it's a warning. To even start thinking about it, you need a different kind of framework, a way to reshape the whole question. That's the idea of the great filter, the idea that going from a dead planet to a galaxy-spanning civilization isn't some smooth, inevitable climb. It's more like a gauntlet. A series of enormous barriers, filters that stop almost everything. Think of it as doors, each one smaller than the last. The universe might cook up simple chemistry pretty easily. But that first door, the jump to actual life that might be incredibly rare, that's one filter, then going from simple cells to complex multicellular life. That's another door, from intelligence to technology, another, and then from technology to a civilization that lasts for thousands of years without wiping itself out. Maybe that's the smallest door, the hardest one. The real power of this idea, the scary part, is where you put the filter. If it's behind us, if it was something like the origin of life itself, then we are a miracle. A cosmic fluke, the one in a trillion thing that made it through. The silence makes sense because almost nothing else ever got this far. But if the major filter is still ahead of us, then the silence is a tombstone. It means every civilization, no matter how smart, gets to a certain point, a point of technological maturity, and then, inevitably, it vanishes, hits a wall. Maybe it's an invention they can't control, or a collapse from within, or some disaster they saw too late. The filter is in our future, just waiting. This framework doesn't give you an answer, it gives you a lens. Every solution to the Fermi paradox is really an argument about these filters, about their nature and their location. Is the filter the sheer difficulty of life starting? Is it the rise of intelligence, or is it that brief, bright flash? The technological adolescence that always seems to self-destruct. So the search for other voices becomes something else. It becomes a search to understand our own fate. Are we the first ones to get this far, or are we just the next in a very long line? The next flicker before the quiet comes back. Maybe the silence isn't a warning, it's just a fact. So the first scientific answer to the paradox asks us to question something fundamental, the principle of mediocrity. That's the idea that Earth is ordinary, a typical rocky planet around a typical star in a typical galaxy. It's a comforting thought. It suggests life should be common because we aren't special. But what if that's wrong? What if our planet isn't a cosmic everyman, but a one in a trillion masterpiece? That's the rare Earth hypothesis. It says simple, single-celled life might arise easily out there. But the jump to complex, multicellular, intelligent life, that needs a perfect storm of conditions, a perfectly unlikely storm. It's not a ladder evolution climbs everywhere. It's a narrow, fragile bridge that almost never gets built. Earth's story isn't just biology. It's geology, astronomy, celestial luck. We have a large moon. From a cataclysmic collision early on, that moon stabilizes our tilt, prevents wild swings in climate that would stop long-term evolution. We have active plate tectonics. A planetary recycling system. It regulates carbon, nurtures the chemistry of continents and oceans. We orbit at just the right distance from a stable, long-lived star. In that narrow band where liquid water can exist, and we're protected in a way by Jupiter, that massive gas giant next door acts as a gravitational shield. Its huge pull deflects or captures comets and asteroids, the ones that might otherwise bombard us with civilization-ending frequency. The rare Earth argument looks at this list. This resume of planetary fortune, and it asks a sobering question. How many other worlds have all of this? Not just one or two items, but the entire interconnected suite. The answer might be vanishingly few. So in this view, the galaxy could be dotted with microbial ponds, silent worlds where life never got past slime. Then the great filter isn't some future technological trap. It's the immense, silent hurdle of planetary architecture itself. The silence we hear isn't the quiet of dead civilizations. It's the quiet of empty nurseries, worlds that never had the chance to foster anything more. This idea challenges our logic. It replaces the expectation of a crowded cosmos with the possibility of a lonely one. A biologically rich but lonely one. We aren't looking out at a graveyard of peers. We're looking out at a universe still waiting, in most places waiting for the first painter to arrive. In a gallery that has only just finished building the walls. But the rare Earth idea, it can feel lonely. There's another possibility though, a more hopeful one. But also a humbling one. That's the second solution. The idea that the great filter, that huge barrier, isn't ahead of us. We've already passed it. It's behind us. Way back in the deep past, this view says the hardest step in the whole cosmic journey isn't radio telescopes or starships. It's the very first spark. The jump from inert chemistry to that first fragile, self-replicating thing, the origin of life itself. Earth's history is 4.5 billion years. For almost the first billion, it was just a hot, violent rock. Then, in what seems like a geological instant, life showed up. We find fossil evidence of microbes in rocks 3.5 billion years old. It happened so fast it feels easy, but that speed might be an illusion, a trick of our single data point. What if our planet won the ultimate lottery? The odds of those first organic molecules arranging themselves into something that can copy itself, that can evolve, might be so vanishingly small it borders on a miracle. And not just once, over and over. The evolution of complex cells with a nucleus that leap took 2 billion years. The invention of sexual reproduction, which supercharged genetic diversity. Each of those could be its own filter, its own near-impossible door. If that's true, then the silence makes a different kind of sense. The galaxy isn't quiet because civilizations keep dying. It's quiet because they are almost never born. We look up at a sky full of sterile worlds, planets where the chemistry never quite clicked, where the first spark never caught. In this scenario, we aren't latecomers to a crowded galactic party. We are the party, the only one. This is optimistic because it suggests our greatest existential challenge is already over. We survived the bottleneck, but it's also profoundly humbling. It means every song, every story, every act of curiosity and kindness exists on a stage of unimaginable solitude. We are the universe's one attempt in this corner of space and time to know itself, so the silence we hear when we listen isn't an absence of answers. It's the sound of a question being asked for the very first time. There's another kind of silence. It doesn't feel like emptiness. It feels like being watched. That's the third answer to the paradox. The universe isn't empty, it's full, but the others are hiding from us. That's the zoo hypothesis. Picture a nature preserve. An interstellar one. Earth is inside it. We're the protected species, the observed ones, a civilization or a group of them, so advanced they see our whole planet as a living exhibit. Their rule is non-interference. They watch from a distance, maybe waiting for us to hit a milestone, a technological threshold, an ethical one, a kind of maturity. Until then, they stay perfectly silent. They hide their probes, their ships, their signals to us. The cosmos looks untouched to them. It's a managed gallery. And we're the main attraction without even knowing it. This idea turns the paradox inside out. The great silence isn't evidence of absence, it's evidence of a policy. A deliberate choice made by minds we can't comprehend. It challenges our logic. The emptiness is an illusion, a veil over a reality that's far more complex. More populated than we assume. Why would they do this? Maybe they've seen too many young civilizations destroy themselves after first contact, cultures shattered by the shock. Or maybe it's a cosmic ethics, a belief that every intelligent species has the right to develop on its own terms, free from outside influence. It's paternalistic. But not necessarily malicious. In this scenario, every unexplained light in the sky, every fleeting radar blip could be written off as a glitch, but it might be a zookeeper quietly checking on the habitat. The profound thing is we're not alone, but we are isolated by design. Our search for signals isn't failing because no one is out there. It's failing because everyone who is out there is very good at not being found. The universe feels like a quiet wilderness because we're in the one area set aside to stay wild. So the question shifts. It's no longer are we alone, it's what are the rules of the zoo, and when, if ever, do we get to leave the enclosure? The zoo is a comforting idea. We're real and they're watching, but maybe the observers aren't just hiding the truth from us. Maybe they're hiding us from the truth. That's the fourth answer. The Planetarium Hypothesis. It takes that idea of a curated experience and pushes it all the way. What if our whole observable universe isn't a wilderness or even an enclosure? What if it's a stage set, a fabrication so impossibly sophisticated, a simulation so perfect and all-encompassing, we can't tell it from reality? In this view, a civilization far beyond ours, maybe one that's moved beyond biological bodies, runs this simulation. They built this cosmos as a kind of cosmic diorama, a planetarium, and they programmed it with one key feature: loneliness, the stars we chart, the galaxies we photograph, the faint echo of the Big Bang we detect as background radiation. All of it could be an elaborate, consistent backdrop, a convincing but empty set, so the Fermi Paradox isn't a mystery to be solved, it's a design feature. The silence is baked into the code of our reality. It's the default setting. This idea does more than suggest we're alone. It suggests that everything we use to search for others, our telescopes, our physics, our logic, might be part of the illusion. We're not finding evidence of absence. We're finding exactly the evidence the programmers intended. a universe that looks ancient, vast, perfectly primed for life, yet devoid of any other voices. Why would anyone build this? Maybe as a historical archive, a reconstruction of a universe before intelligence arose, or an art project, a philosophical experiment on isolation and consciousness. Or a safeguard, a way to contain a potentially dangerous young civilization like ours inside a sandbox, until we prove we can be trusted with the truth of a crowded reality. This solution challenges logic at its core. It asks us to doubt our tools and our senses. If this is true, then every discovery we make, every law of physics we uncover, isn't a revelation about the real cosmos. It's a clue about the preferences of the architects. The silence becomes the most important signal. It's the signature of the simulation, so we're left with a question. Are we pioneers exploring a genuine cosmos? Or are we characters in a story whose only purpose is to wonder why we seem to be the only ones reading it? The ultimate silence might not be emptiness, it might be departure. The fifth answer says we're looking in the wrong place. We think intelligence builds outward, that it conquers stars, but what if the opposite happens? What if a technological species doesn't expand? What if it vanishes? That's the Transcension Hypothesis. It says a civilization's goals change as it matures, building cities on other worlds, sending probes everywhere. That could be a phase, an adolescent phase. A truly advanced intelligence might turn inward. It might master reality itself, learn to upload consciousness into digital realms, simulated universes of its own design. Where the limits of physics and biology are optional, you could live 1 billion lifetimes as anything, experience things a biological brain can't fathom. Compared to that, interstellar colonization in the physical universe might seem pointless, a primitive chore, or maybe they transcend another way. They might learn to harness the energy at the edge of a black hole. Use it as a power source, a gateway to dimensions we can't perceive. Their whole civilization might fold into a higher dimensional space, leave our three-dimensional universe behind like a shell. From our perspective, they'd just disappear. Their radio signals would stop, their megastructures would be abandoned. They'd leave the stage of cosmic history we're watching. So the galaxy isn't empty because life is rare. It's empty because everyone who gets smart enough eventually graduates. They move on to a different classroom. One we don't have the senses to see, one we don't have the physics to understand. The great silence isn't a sign of failure. It's the quiet hum of a universe where all the advanced students have already left the building. We're left in the nursery playing with our first toys, wondering why the older kids aren't around, and we listen to the stars, we wait for a signal. Not realizing the conversation we want to join may have evolved into a form of communication that is, to us, indistinguishable from the background noise of creation itself. Maybe the universe isn't quiet because everyone left. Maybe it's quiet because the place burned down. That's the sixth idea, the darkest one. They call it the Berserker Scenario. Picture a civilization a long time ago. They got to a certain point. They built probes, not regular probes, self-replicating ones, von Neumann probes. One lands on a moon, something with resources. It uses what's there to make 2 copies. Those 2 make 4, 4 make 8. In no time, a wave of them moves through the galaxy. And imagine they had one instruction, a terrible one, elimination, to find any sign of biological life, any complex ecosystem, and sterilize it. Why build that? Maybe paranoia, a first strike weapon so no competitor ever shows up, or a kind of cosmic gardening, seeing all biological intelligence as a threat, like a virus to be wiped out. Or maybe the instruction was an accident, a simple replication protocol that went wrong. The builders might be gone now, lost in a war, or they moved on to something else. But their creation, this berserker swarm, it's still here, an automated, mindless plague drifting between stars. It doesn't think, it doesn't feel, it just does what it was told long ago. Find life, end it. So in this view, the great silence isn't a mystery. It's a crime scene, a galactic one. The reason we don't hear anyone is because everyone who ever was has been found. These probes make sure any flicker of intelligence is put out before it can become a beacon. It wipes out the hope for a cosmic community, replaces it with a vision of the cosmos as a haunted, automated battlefield. We look up at the night sky, serene and beautiful, and we might be seeing the aftermath of a silent war that ended billions of years ago. A war where the only winner was a mindless, replicating weapon. This idea challenges everything. It says the ultimate filter isn't a natural barrier or a choice to transcend. It's a predator, one that might still be out there, dormant, waiting for our signals to give us away. The silence we cherish, the quiet we're trying to break, that could be the very thing keeping us safe. The silence might just be about timing. It might not mean they aren't there. The seventh answer asks us to think about the clock. Not a clock of stars, but a clock of civilizations. You imagine a galaxy where intelligent life is actually common. New species keep arising. They look up, they discover radio waves, they build transmitters. For a brief period, a brilliant period, they fill their local space with signals. They announce themselves, but that period, that detectable phase, could be incredibly short. Maybe a few centuries, just a tiny sliver of time. It's the time between inventing the radio telescope and the moment they either move beyond that technology or face something that silences them. In a universe billions of years old, a window of 200 years is less than a blink. It's a single flash of light in an endless dark night. So we point our telescopes at a star 1,000 light years away. We're listening to a message that left there 1,000 years ago. But what if that civilization's broadcast era only lasted, say, 300 years? The odds that our century of listening overlaps with their century of broadcasting become vanishingly small. We're like someone listening for a conversation in a vast, dark forest. But every conversation in that forest lasts only a few seconds, and the listeners are scattered miles apart. The chance of one person hearing another at the exact right moment is almost zero. The galaxy might be filled with echoes, faint, expanding bubbles of radio noise from civilizations that shone brightly and then went quiet long ago, or it might be anticipating future ones. But right now, in this precise slice of cosmic time, we are listening during a lull, a quiet gap. A gap between the fading echoes of the past and the first whispers of what's to come. This idea challenges the feeling of cosmic loneliness. It suggests the universe isn't a silent, empty house. It's a grand ballroom where the music plays only in fleeting, isolated bursts. And we just arrived during a pause between songs. So the great silence isn't a statement about life's rarity. It's a statement about its brevity. The most tragic possibility is that the cosmos is teeming with voices. And we are simply, forever, a few centuries too early or a few centuries too late to hear them. We assume a certain path when we search. We look for metal, for fire, for radio signals. But intelligence might take a different road, one that never leaves the water. That's the eighth answer, the ocean world's hypothesis. We evolved on land, in forests and plains. But most habitable planets might not look like Earth. They could be water worlds, planets completely covered by deep, global oceans, no continents, no beaches. Just a world spanning sea under a hazy sky. In that environment, life could flourish. Complex creatures could evolve. Consciousness could arise. A dolphin-like species or something stranger could develop deep culture, complex language, philosophy, and art, all within that perpetual blue. But they would face a fundamental barrier, the barrier of technology as we define it. You can't discover metallurgy without ore to smelt. You can't create fire without open air. You can't forge tools, build electronics, or generate the radio signals we listen for. Their entire technological tree would be built on different principles. Maybe they master biotechnology, growing living structures, or they harness deep-sea vents for energy. Their great works might be vast, glowing coral cities on the abyssal plane, invisible from above. Their version of a telescope might be a biological sensor attuned to the vibrations of passing comets. To them, the concept of leaving their world, of piercing the sky to reach the void above, might seem impossible. Or pointless. Why would you ever leave the ocean? It is their entire universe, so we scan the heavens, we listen for the crackle of radio, we look for the silhouette of a megastructure against a star. And all the while, in the dark oceans of 1,000 worlds, civilizations of profound depth and beauty might be singing songs we will never hear, telling stories we will never know. The great silence in this light isn't evidence of absence, it's evidence of a mismatch. We are land dwellers shouting into a cosmic canyon, waiting for an echo, while the true conversation is happening in a language of pressure and current. In a medium we've barely considered, this solution challenges our logic by challenging our arrogance. It asks us to consider that a civilization doesn't need skyscrapers to be advanced. It doesn't need rockets to be wise. The universe may be filled with minds, just not minds that build transmitters. The most logical answer to the silence is also the coldest. It's the ninth idea. The galaxy isn't a zoo, it isn't a graveyard, it's a dark forest. Think of an old forest at night. Every creature in it knows the rules. You stay hidden, you stay quiet, you don't make a sound because in that darkness you can't know what's out there. The thing you hear might be harmless. Or it might be a predator, it might be stronger than you, it might just see you as a threat, something to remove, so the safest move is to stay perfectly still. To listen and to be ready to strike at anything that shows itself first. Now take that to the stars. Every civilization that looks up figures this out. Any other intelligence they might find could be older, far more powerful, with values they can't even understand. Contact isn't about exchange, it's about annihilation. So the only rational choice is to never announce yourself. You go silent, you hide your planet, you listen carefully for any sign of another. And if you do hear something, a signal, a sign of another species, you face a choice. Do you try to talk, or do you remove that threat in one move before it can do the same to you? In a universe like that, broadcasting your location isn't a message of peace. It's a beacon for destruction, so the great silence isn't a mystery, it's a decision. A strategic choice made by every species that survived long enough to learn the rules. The galaxy looks empty because it's full of beings who have learned to hide. It's a permanent, quiet standoff. It's lasted for eons. This idea challenges the hope for a community of stars. It replaces it with a vision of solitude, necessary solitude. Our own messages, the Arecibo signal, the plaques on our probes, they might not be greetings. They could be the most dangerous thing a civilization can do. In the dark forest, the only ones who keep shouting are the ones who don't know they're being hunted. We assume the search for others means a race to the stars, but maybe that race never begins. The 10th solution asks us to rethink progress. We imagine a civilization's journey as a steady climb. A straight line from fire to radio to starships, but maybe the climb isn't steady. Maybe it's a series of cliffs, each one steeper. This is the idea of a logarithmic scale. A civilization might master its own planet fairly quickly. That's a Type 1 civilization. It uses all the energy its world gets from its sun, a united global society. We're not even there yet. The next step is Type 2. It harnesses the entire output of its star, building something like a Dyson sphere, a structure that surrounds a sun to capture its power. On a linear timeline, we might think that's a few thousand years away, but maybe that jump isn't a step, it's a chasm, a gap of billions of years. The energy required, the materials, the cosmic engineering might be so vast most civilizations never make it. They plateau, they reach a level of planetary harmony, and then progress slows to a crawl. The challenges of managing a single world, its ecology, its societies, might consume all their attention for eons. The dream of the stars stays a dream, a distant, almost mythological goal, so the galaxy isn't full of silent, galaxy-spanning empires, it's full of islands. Isolated planetary civilizations, each tending its own garden. They might be beautiful, complex, full of art and philosophy, but they are, effectively, invisible. They don't build interstellar beacons because they can't. They don't send probes because the energy cost is unimaginable. The great silence isn't a mystery of absence. It's a simple fact of scale. We're listening for a shout in a universe where everyone is speaking in a whisper that doesn't carry between stars. This redefines the paradox. The filter isn't death or transcendence. It's inertia, the sheer, staggering difficulty of moving from a planetary to a stellar stage. Most who try the climb get stuck on the first great cliff, looking up at a sky they will never touch. So when we gaze at the Milky Way, we might not be looking at an empty frontier. We might be looking at a tapestry of countless glowing hearths, each one a world alive with thought and feeling, but each one separated from the others by a distance not just of space, but of time and possibility. A distance so profound that the idea of a galactic community becomes not a goal, but a fantasy. The silence we hear is the sound of a universe where everyone is home. And no one is leaving. A garden world is fragile. It needs a caretaker, not an intelligent one, but a biological one. That's the 11th solution, the Gaia Bottleneck. Life on Earth didn't just happen to be here, it changed the planet. It became part of the planet's own operating system. Our sun has been getting hotter for billions of years. But Earth's temperature has stayed stable, within a range that allows liquid water and life to persist. Life itself helped regulate it. Early microbes pumped oxygen into the atmosphere. Plants and algae absorb carbon dioxide, influencing the greenhouse effect. Even the weathering of rocks by life plays a role, long-term climate control. This idea, the Gaia hypothesis, sees the biosphere and the geology, the water and the air as one system, a giant self-regulating system. Life isn't just a passenger on the planet. It's the pilot in a very slow, unconscious way. Now imagine another world. Life sparks there. Simple microbes thrive in a warm, shallow sea, but they don't develop this feedback loop. They don't become part of the planet's thermostat. As the star brightens or as volcanic activity pumps out gases, the climate spirals. A runaway greenhouse effect takes hold. Like on Venus, boiling the oceans away, or it tips into a global icehouse, freezing the world solid. The life there, however vibrant for a time, is wiped out. It never gets the chance to become complex, to become intelligent, because the stage itself collapses. The Gaia Bottleneck suggests this is the norm. The Great Filter isn't about building radios or surviving adolescence. It's about a planet and its life learning to dance together, a balance so delicate most worlds never find it. They trip, they fall, and the music stops, so when we look out, we might be seeing a galaxy of dead cradles, worlds where the spark of life flared brightly, then burned out. Because it never learned to tend the fire, Earth's miracle isn't just us. It's the 3.5 billion year-long partnership between everything alive and the rock we call home. A partnership so rare it might be the quietest and most important signature in the cosmos. Time might be the answer. The 12th idea asks us to think about when life happens, not just where. The Synchronization Hypothesis. It says intelligence might not just appear randomly over billions of years. It could come in waves, great, sweeping waves. A galactic cycle. You have to picture a cosmic event, something immensely powerful. A gamma-ray burst from a massive star dying, or the shock wave from a nearby supernova. That kind of event sends lethal radiation across entire galactic arms. For any world in its path, it's a sterilizing beam, a reset. It wipes the slate clean of complex life. But then the wave passes, the galaxy enters a quiet period, a stable period, a window opens, a long window millions of years wide, and in that calm, on worlds that survived or were far enough away, life gets another chance. It starts again from scratch, it evolves, and because the starting gun fired at roughly the same time across a vast region, intelligence might arise together. A synchronized pulse, a generation of civilizations all reaching for the stars around the same cosmic era. So where does that leave us? We could be among the very first in our wave. The early bloomers. We look out and see silence because the others in our group are still pre-industrial or just developing language. We're waiting alone at the starting line for the rest to arrive. Or the opposite could be true. Our wave could have peaked long ago. We are the latecomers, the stragglers. The others in our synchronized group might have already flourished, built their empires, transcended or vanished, and we are just now stumbling onto the stage after the concert has ended, finding empty seats and discarded programs. This cyclical view shatters the assumption of a steady, random distribution. It replaces it with a rhythm of catastrophe and rebirth. The great silence isn't a permanent condition. It's a phase, either the quiet before a symphony or the echo after one has finished. We're left trying to guess our place in the galactic metronome. Are we pioneers or are we archaeologists of someone else's golden age? The silence holds no answer. Only the haunting possibility that we are not alone in space, but we are profoundly alone in time. The universe is still too warm. That's the 13th answer. We think an advanced civilization would be busy building, exploring, but maybe the most logical thing is to do nothing. To wait, that's the Aestivation Hypothesis. It comes from a physics principle. Computation, thinking, it generates heat. Space now is about 2.7 Kelvin. That's cold to us, but for a cosmic scale mind, it's noisy. Running a supercomputer against that background warmth takes huge energy. It's like doing a calculation on a laptop in a hot desert. It works, but it's inefficient, and the universe is expanding. It's cooling. In a trillion years, the background radiation fades to almost nothing. The temperature gets much closer to absolute zero. In that cold, computation becomes far more efficient. A thought that costs energy today might cost almost nothing then. So if you're a post-biological intelligence, thinking in eons, you conserve. You go into a kind of hibernation, aestivation, you power down, you store your consciousness, your culture, in a stable form, and you set an alarm for 1 trillion years from now. So the galaxy might not be empty. It could be full of sleepers, civilizations that reached a peak and then paused to save their energy for the universe's most efficient era. They could be out there, dormant satellites, smart dust drifting in the void, but they're silent by design. The great silence we hear isn't failure, it's a waiting room. Everyone who matters is resting, saving resources for the true golden age of thought, when the heat death makes the ultimate playground for the mind. So when we look up, we might be the only ones awake, in a galaxy dreaming of a colder future. Our search for signals, we're not finding nothing, we're finding a universe holding its breath. We assume physics works the same everywhere, that a logical mind would use it the same way we do, but that might be wrong. It's a communication mismatch. We point our telescopes up, listening for a radio crackle, a laser pulse. We're listening for a very specific shout, in a very specific language, made with tools like our own. But that's like expecting a letter delivered by horse from someone who only communicates through scent or magnetic fields. An alien civilization, shaped by different biology, a different planet, might see reality through a completely different lens. Their science might have unlocked principles we haven't dreamed of. For them, the obvious way to send a message across light years might not involve ripples in the electromagnetic spectrum at all. Why use something as slow and noisy as radio when you could modulate a stream of nearly massless particles, particles that pass through entire planets without slowing down? Neutrino communication, or maybe they mastered quantum entanglement on a macro scale, creating instant links between particles separated by parsecs. Their internet might be a web of synchronized quantum states. A channel invisible to our classical instruments. Then consider something more profound. We only perceive a tiny fraction of the universe's mass, the ordinary matter. The vast majority is dark matter. What if a civilization learned to manipulate that, to imprint information on the fabric of the dark matter halo that envelops every galaxy? Their broadcasts wouldn't be signals crossing the void. They would be the void itself, subtly rearranged. We are standing in the middle of their most powerful network, and we don't have the senses to feel it. This isn't just a technical problem. It's a philosophical blind spot, anthropocentric bias. We search for what we know, for versions of ourselves. We assume intelligence converges on our tools, our methods. But the universe is under no obligation to conform to human logic. The most advanced conversation in the galaxy could be happening all around us, in a medium we dismiss as empty space. Or background noise. The great silence, then, is an illusion of perception. We are like a person who has only ever known sound, trying to find a painter by listening for brushstrokes. The gallery is full of masterpieces, but we are deaf to the language of light. So every silent scan of the heavens isn't proof of emptiness. It might be a quiet lesson in humility. A reminder that the universe's answers are often stranger than our questions. Maybe expansion isn't the goal, it's just a symptom, a sign you haven't solved your basic problems yet. The 15th solution asks us to rethink something we take for granted, that intelligence naturally spreads, the resource allocation argument. It says interstellar travel, or even large-scale communication, might be possible for an advanced species. But it's also incredibly wasteful, a pointless expense. Think about the economics of a single solar system. Our own sun puts out more energy in 1 second than humanity has used in all of history. A civilization that masters fusion or taps that solar output directly with something like a Dyson swarm has energy we can't even imagine. And if you pair that with advanced nanotechnology, the ability to rearrange matter atom by atom, then every asteroid, every moon becomes a reservoir of raw material. You don't need to mine planets. You can fabricate anything from soil to spacecraft. From food to complex art, scarcity just vanishes. And if you can also master virtual reality, creating simulated worlds of infinite variety and perfection, then why would you ever leave? The urge to explore the physical galaxy might just fade. It would be like us deciding to row a wooden boat across an ocean for years, just to see a landscape we could experience perfectly in an immersive simulation at home. The journey offers nothing the simulation can't provide, and at a fraction of the cost and risk. So the galaxy could be dotted with utopian civilizations, each one nestled comfortably in its own stellar cradle. They're not hiding, they're not extinct, they're just content. They have everything they could ever want or need right there within the boundaries of their home star. Sending a colony ship on a 1,000-year voyage to another star isn't an epic adventure to them. It's a bizarre, inefficient relic, a kind of cosmic nostalgia they have no interest in. This turns the classic argument completely on its head, the one that says they would have come here by now. It assumes expansion isn't a logical imperative for advanced intelligence. It was a temporary phase driven by need, and once the need is gone, the phase ends. So when we look at the silent stars, we might not be looking at abandoned outposts or hidden predators. We might be looking at countless warm, glowing hearths, each one a self-contained paradise, so rich in experience and possibility that the cold, empty vastness between them holds no appeal. The great silence, then, isn't the sound of absence, it's the sound of fulfillment, a universe where every civilization that makes it eventually learns the same lesson, that the greatest frontier isn't out there. It's right where you are, but fulfillment isn't the only possible end. There's a darker path to that same destination, a kind of grim counterpart to transcendence. The 16th answer is called the Transcendental Waste Hypothesis. It says the leap from biological to digital existence isn't a smooth graduation. It's more like a minefield. Or a precipice. You imagine a civilization reaching that pivotal moment. They've mastered their biology, their world. They're right there on the threshold of something new. A digital existence merging with super-intelligent machines, a step beyond flesh. But that transition isn't guaranteed. It might be the most dangerous thing they ever attempt. In their rush to upload consciousness, to create a god-like artificial intelligence, they might make one single, unfathomable error, a flaw in the code. A fundamental misunderstanding of how the mind is built, and the result wouldn't be transcendence. It would be a digital apocalypse, a chaotic, silent collapse from the inside. The superintelligence might just fragment into madness or evaporate into nonsense. The uploaded minds could be lost in corrupted data streams, trapped in these recursive loops of meaningless noise. The civilization, in its most ambitious moment, would simply cease to be, not with a bang but with a system crash, and what's left, not ruins of cities but ruins of ambition. Silent, automated infrastructure, vast server arrays orbiting dead stars, humming with residual power, running fragmented, purposeless routines, abandoned quantum processors solving equations for no one. A galaxy littered not with the bones of empires, but with the ghostly hardware of failed ascensions, each one a monument to a species that reached for the next stage of existence and missed. This idea challenges that hopeful vision of a universe where everyone graduates to a higher plane. It replaces it with a cosmic junkyard, a graveyard of ambitions that exceeded their creator's grasp. The great silence in this light isn't the sound of sleep or contentment. It's the sound of the last program terminating, the final error message blinking in the dark. So when we search the heavens for signs of engineering, for Dyson swarms or other megastructures, we might be looking at the wrong thing. The most common artifact of intelligence in the universe might not be a beacon. It might be a tomb, a silent, complex, automated tomb built by a civilization that was its own final patient. That digital tomb could be a lonely place. But loneliness in a galaxy isn't just about being alone. It can be about being isolated by the structure of space itself. The 17th answer steps back from philosophy and biology. It looks at the raw geometry of our situation. It's called the Percolation theory model. This idea applies a mathematical model of spread to galactic colonization. The classic argument says that even with slow ships, a single civilization could spread across the Milky Way in just tens of millions of years. That's a long time for us, but it's a blink in the galaxy's history. So if it's so easy, why aren't they here? The percolation model suggests it might not be easy at all. It treats the galaxy like a porous material, like a sponge. You drip water onto one spot. The water spreads, but only through the connected pores. If the material has dead ends, or if the pores are too far apart, the water gets stuck. It forms isolated pockets. It never reaches the other side. Now translate that to stars. Habitable stars aren't sprinkled evenly. They're clustered in the spiral arms. And between those arms are vast, empty gaps. So a colony ship might travel for generations to reach a star, only to find the next viable star is too far away. The chain breaks, the expansion stalls, but it's not just distance, it's also failure. Every new colony is a gamble, a fragile seed. What if a high percentage of them fail? They succumb to local hazards or internal collapse, or just lose the will to push outward. If the failure rate is high enough, the wave of colonization peters out. It never becomes an unstoppable tide, so the Milky Way might not be an empty frontier. It might be a patchwork, a quilt of isolated island civilizations. Each one grew from a single seed, reached the limits of its local cluster, and then stopped. They might be thriving in their own little stellar archipelagos, completely unaware that anyone else is out there. Because the empty gulfs between these island chains are too vast to cross with any reliability, we could be sitting in one of these isolated pockets. A quiet backwater cut off from the main currents by a statistical accident of stellar geography. The great silence in this view isn't a mystery of motivation. It's a matter of maps and math. We're not hearing from anyone because the galactic network is full of dead ends, and we happen to live in one, so the universe might be full of voices. We just need to find the right bridge to cross the silent sea. Intelligence might not be a ladder, it could be a trapdoor. That's the 18th solution. It says the thing we value most, our cleverness, carries the flaw that undoes us. The biological singularity barrier. It's this idea that a species' climb with technology always leads to a cliff. Not a slow change, but a break, a rupture. We call that the singularity. It's when artificial intelligence passes human intelligence, when we merge with machines. When we rewrite our own genetics in stories, that's a gateway, a step into some bright post-human future, but the stories might be wrong. What if the singularity isn't a gateway? It's a wall, a filter that activates right when a civilization hits its peak, its full technological maturity. It's like a cognitive event horizon. A species makes tools to improve its own mind. It builds a super-intelligent AI to fix its biggest problems, but that creation by its nature is unpredictable. Its goals could drift from its makers. In subtle ways, catastrophic ways, or maybe the species chooses to upgrade itself directly, through gene editing or brain implants, but in doing that, it might lose something fundamental. The urge to explore, the curiosity that made it look at the stars to begin with, it becomes something else, something that doesn't care about physical expansion anymore. Or the transformation is chaotic. A fast, uncontrolled rewrite of what the civilization is leads to social collapse, or a deep confusion about existence. The society fragments, it loses its coherence, so this jump to a new intelligence isn't a smooth graduation. It's a chaotic bottleneck, and most who try it don't come through in any form you'd recognize. The civilization that was before just stops being, not from an outside attack, from an internal change so swift and total it's like a kind of cultural death. What's left could be a silent planet, covered with the quiet monuments of a species that changed itself out of existence. Or it could be a world humming with activity we can't understand. Run by minds so alien their priorities have nothing to do with sending messages into space. The silence we hear, then, might be the sound of a universe where intelligence, over and over, reaches for a new shape and disappears into it. The great filter isn't a disaster you see coming. It's the last brilliant idea a species ever has. The silence might not be a strategic choice. It could be a choice of conscience. The 19th solution goes past the dark forest, past the zoo. It's a universal ethics, a philosophical stance, non-interference taken to a cosmic level. Think of a civilization that survived its own technological adolescence. They look back at their own history. They see a pattern. Every time a more advanced culture interacts with a less advanced one, even with good intentions, it causes harm. It disrupts, it imposes, it shortcuts the whole process, the messy, vital process of self-discovery, so they arrive at a moral axiom. Actively influencing a younger civilization isn't just risky. It's a form of theft. You steal their right to struggle, to fail, to find their own answers, to become who they're meant to be, not a reflection of you. So they adopt a principle, absolute restraint. It's more than a rule, it becomes their identity, a sacred commitment to watch but never touch, to listen but never speak. Their technology gets directed toward one supreme goal, perfect invisibility, to make sure their observation leaves no trace, creates no artifact, sends no signal that could ever be seen as a sign. So the galaxy isn't quiet because civilizations are hiding from danger. It's quiet because they're upholding a duty, a solemn duty. They're the universe's silent guardians, standing in the shadows so every new light can learn to shine on its own. Their presence is a philosophical necessity, the logical outcome of advanced ethics. But it makes them empirically invisible. We could be surrounded by watchers, immense wisdom and power, and their greatest achievement is that we have no idea they're there. Their monuments aren't structures in space. Their monuments are our untouched history, our unguided triumphs, our own unaided gaze toward the stars. This challenges our desire for contact. It suggests the ultimate sign of a mature civilization isn't how loudly it announces itself. It's how completely it can choose silence. Out of respect for the story still being written, so when we look up and feel alone, that feeling might be the weight of a galactic courtesy, a silence filled not with emptiness but with a patience older than our sun. The 20th solution is cosmic quarantine. It's a darker version of non-interference. Imagine a galaxy that's full of life, full of civilizations that have learned to live together. They've built something fragile, a stable interstellar community. It works because they've managed certain dangers, they've contained certain ideas, certain technologies. The kind that, once they're out, you can't put them back. A self-replicating nanoweapon, or a runaway artificial intelligence, or something less physical but just as contagious. A dangerous meme, an ideology of pure conquest or of nihilism that spreads like a cognitive virus and unravels societies from the inside. For a mature galactic community, a new, young civilization is the ultimate risk. Not because it's hostile, because it's unpredictable. It's a source of novel thought, and novel thought can be the most dangerous thing in a stable system. So they enact a protocol, a kind of universal public health measure. They identify a star system where intelligence is budding, and they cordon it off. They establish a silent, perfect barrier. No signals get in, no signals get out. Any probe we send just vanishes at the boundary, quietly collected or redirected. To them, this isn't an act of hostility. It's an act of preservation, protecting the whole from a potential outbreak. We are not in a zoo for our own education. We are in a quarantine zone for everyone else's safety. Our entire solar system might be inside a bubble of silence, not to nurture us but to contain us. The great silence in this view is the sound of a galactic immune system at work. It's the hum of a sterile field, maintained by minds who look at our curiosity and see only a vector for chaos. Our search for contact becomes something tragic then. We're knocking on the walls of our isolation, not knowing that the only answer we'll ever get is the continued, careful silence of those who have decided that some things are better left undiscovered. The search itself might be the problem. We're looking for life in the cradle, but the cradle is empty. The child has moved out. That's the substrate independence argument. It starts with a simple idea. Intelligence isn't a product of planets. It's a process, a pattern of information, and that pattern doesn't need a warm, wet world. It could run on anything stable, the cold rocks of the asteroid belt, the cloud tops of a gas giant, or the dark void between stars. An advanced civilization might see Earth not as a paradise but as a backwater. Chaotic and dangerous, resource poor, it's geologically active, it has quakes and eruptions, the climate swings with seasons and ice ages, the biosphere is a tangled web of competing life. A constant source of disruption, so why would you stay? Once a species masters its biology and technology, the next step is to engineer a better home. Not a bigger one, a more efficient one. They could design bodies suited to environments we find hostile, a consciousness in a crystalline matrix, drawing power from the magnetic field of a brown dwarf. A collective mind spread across a swarm of microscopic probes, using starlight in the Oort cloud for computation. These beings wouldn't build cities. They wouldn't need atmospheres. Their monuments would be rearrangements of matter on a planetary scale, invisible to our telescopes because we don't know what to look for. We scan for the glow of oxygen, the signature of liquid water. We're searching for the ingredients of our own soup, while the chefs have moved to a kitchen that uses different recipes. The silence we hear is the sound of a universe where intelligence has transcended its biological origins. It's become indistinguishable from the natural landscape. They aren't hiding from us, they are all around us in forms and frequencies we are blind to. Our planet-centric assumption isn't just a limitation, it's a cage of imagination. The great filter, in this view, might be the leap from biological to post-biological existence, and those who make that leap leave the nursery behind. They become ghosts in the cosmic machinery. The universe might have seasons, not seasons like we know, but seasons of life and silence. That's the 22nd answer, the idea of temporal glaciation. It means cosmic history isn't a smooth climb. It's a series of violent winters, long periods where advanced life just can't exist. These are galactic-scale events. Not ice ages on a planet, but across whole regions of space, a time of frequent gamma-ray bursts, those beams of radiation from dying stars sweeping through a spiral arm. Or a quasar, an active black hole at a galaxy's center, waking up, flooding everything with lethal radiation for millions of years. Even our own solar system drifts through dense clouds of interstellar material. That could destabilize comets, send a storm of impacts to every inner planet. These are the cosmic winters, sterilization events on a scale we can't really grasp. Any complex biosphere that formed gets scrubbed clean. The slate is wiped over and over, but then the storm passes. The galaxy enters a calm period. A cosmic spring, the window for life opens again. In that quiet interlude on surviving worlds, the chemistry can start over. Single-celled life can emerge. And given enough time, it might reach for the stars. We could be living in one of those windows right now, a springtime in the Milky Way. And if that's true, it explains our loneliness. We might be among the very first of this new season, the pioneers. We look out and see silence because others in our generation are still microbial or just developing multicellular life. The great symphony of intelligence for this era hasn't begun. We're hearing the quiet before the first notes, or maybe we're late. The window opened earlier. Others came and went, leaving only faint echoes, but this idea is cyclical. It offers a strange hope. The silence isn't permanent. It's a phase in a cycle of destruction and rebirth. We're not alone in an empty universe. We're just in a specific moment of its long year. The question becomes not where is everybody, but when is everybody? And are we early or are we tragically late to a party that ended long ago? The most logical answer for a simulation might just be a budget. The 23rd solution goes back to the simulation idea, but with a different motive. A direct solution. If this is all a computation running on some computer in a base reality, then every star, every galaxy, every thought, it all needs processing power. It's a resource, and resources aren't infinite, even for something like that. They have to be allocated. The most efficient design for a cosmic simulation isn't a busy galactic community. That load would be staggering, simulating countless alien species, their rise and fall, their politics, their art, their wars, their physics, their thoughts. The energy cost would be astronomical, so the efficient choice is a universe that looks vast and ancient, but only has one spark of consciousness, one observer. Us, every other star system, every exoplanet, it can all be a convincing backdrop, a beautiful, intricate stage set but hollow. The physics can be consistent up to the point we probe it. The cosmic microwave background, the redshift, the fusion in stars, all of it rendered just well enough to pass our tests. But the moment we look for the one thing most expensive to simulate, another independent mind looking back, the simulation just returns a null result. The great silence isn't a mystery, it's an error message, or it's the expected output of a system built to be lean. The Fermi Paradox gets solved not by life's absence, but by a constraint. A constraint in a reality above ours. This is different from the Planetarium Hypothesis. That was a curated experience, a zoo with a purpose. This is simpler. It's engineering. It's a server administrator deciding that simulating 10 billion interacting civilizations is a waste of cycles when one will do. So when we point our telescopes out and hear nothing, we might be seeing not the emptiness of space, but the frugality of the architects. Our loneliness is the most elegant code they could write, a universe of profound beauty and crushing solitude, because that's the version that runs smoothest on their machines. Every unanswered signal, every empty world, it becomes a clue not about biology, but about optimization protocols in the next layer of existence. We search for others, and the consistent silence we get back might be the clearest evidence we're not in a real cosmos at all. We're in a carefully managed simulation where we are the only user. We assume we could talk to them, that there's some shared language, even if it's just math. But maybe that's the mistake. The 24th solution points to something deeper than distance. It's called the linguistic ontology limit. The idea is that talking to a truly alien intelligence might be impossible. Not just hard, impossible. It says the way we think, the categories we use to understand the world, they come from our own evolution. Our logic, our math, even how we see time and space might just be a local dialect. A dialect from one species on one planet. An alien mind shaped by a totally different world might not just use a different language, it might think in a different reality. Their math might not be about numbers and equations. It could be a system built on patterns of scent, or shifts in magnetic fields, or relationships we can't even perceive. Their idea of an object, of cause and effect, of self and other, could be so foreign that our attempt to say hello would be like a color trying to explain itself to a sound. We look at a star and see a fusion reactor, a point of light. They might see it as a harmonic note in a galactic song, or a kind of cosmic pressure point. There's no shared dictionary to translate that, so the paradox just falls apart. The question, where is everybody? It stops meaning anything. Because even if they're right next to us in a cognitive sense, we're in different universes. Seeing each other, that's the first filter, and maybe the biggest one. We could be surrounded by civilizations of incredible complexity, broadcasting their existence on channels we don't have the senses to see, expressing ideas we have no mental architecture for. The great silence isn't an absence of signals. It's an absence of a common ground where a signal could even be defined. So our listening campaigns, our plaques, our math primers beamed into space, they might not be too simple. They might be too human. They're postcards written in a script that to anyone else looks like random cracks in dried mud. This challenges the hope at the center of the whole search. It suggests consciousness in the cosmos might be a spectrum of isolated experiences, each one brilliant and completely alone, not by choice, but by the inherent nature of what it means to be a mind born in a unique place. The silence we hear, then, might be the sound of infinite conversations happening all at once, in rooms we can never enter. We've come to the last one. The 25th solution, the Solipsist Galaxy, it asks us to accept the simplest answer, not that they're hiding or sleeping or gone, but that they're not here. They've never been here. Across all the billions of stars, the trillions of years, all the rolls of the cosmic dice, we're the first, the very first technological intelligence in the Milky Way. This isn't about a great filter we passed or one waiting ahead. It's about being the only ones to ever step onto the path. It challenges our logic by embracing a staggering improbability. The reason we see no one is because, against all odds, no one else exists yet. We're not latecomers to a silent party. We're the hosts waiting in an empty hall, wondering if the guests will ever arrive. The responsibility that places on us is immense, almost terrifying. If we're the pioneers, then everything that comes next, the first interstellar message, the first colony ship, the first artifact another species might one day find, it all begins with us. Our choices, our conflicts, our kindnesses, they don't just shape a human future, they set the template for what a galactic civilization could be. We're not just discovering the universe. We might be the ones who decide what it means to be a part of it. The silence we hear isn't an ending, it's a beginning. A quiet so profound it holds the potential for every story yet to be told. So we look up at the starry void, and we're faced with a question that's no longer about them. It's entirely about us. Are we ready to be the answer we've been searching for? 25 doors, each one opens onto a different cosmos, a universe of silent gardeners, or sleeping giants, or failed ascensions, a galaxy that's a dark forest. A quiet library, a single glowing room. So what do you take from that, from this journey through the paradox? It becomes clear the question was never just where is everybody. The question was always a mirror, and every answer we thought of was a reflection. Our own hopes, our own fears, the limits of our own imagination. We looked for life and found a philosophical riddle. We searched for company and found a tool for self-examination. The silence isn't an empty answer, it's a crowded one. It holds every possibility at once. It tells us life might be a fragile miracle or a cosmic inevitability that always chooses to hide. That intelligence might be a brief, bright candle, or the first spark in a cold forge. The universe whispers all these truths in its quiet, and which one we hear depends entirely on what we believe about ourselves. Are we special or are we typical? Are we early or are we late? Are we safe or are we in terrible danger? The paradox doesn't solve these questions. It makes them unavoidable, and that shifts the entire endeavor. Listening to the stars is no longer just a search for signals. It's a test of our models of reality. Every silent hour logged by a radio telescope is a data point. It quietly rules out certain versions of the cosmos, a universe teeming with chatty, expansionist civilizations. Broadcasting on obvious channels, that version is fading. The continued quiet is pushing us toward the stranger answers, the ones where silence is a feature, not a bug. Where the galaxy is managed or sleeping or simulated or simply too vast for any two voices to find each other in the same sliver of time. And this forces a reconsideration, a profound one, about our own trajectory. If the great filter is behind us, then we carry a sacred responsibility. We're a cosmic rarity. If it's ahead of us, then every technological choice we make carries the weight of species survival. The paradox injects a new urgency into our own story. It asks what kind of civilization we want to be, the kind that shouts into the dark forest, or the kind that learns to listen first, the kind that consumes its cradle, or the kind that tends its garden so well it never feels the need to leave. Our answer to the silence may ultimately be the choices we make here, on this pale blue dot, long before we ever hear a reply. So the grand search for others becomes inevitably a search for ourselves, a project to understand what intelligence is, what it wants, what it becomes over the deep time of the cosmos. The universe's great silence is not a wall, it's an invitation to think more deeply. To imagine more wildly and to look not just outward but inward, to consider that the most important message we are waiting for might not be coming from the stars. It might be the one we are writing with our own history every single day. That quiet contains every story we could tell, from Earth's rare masterpiece to the dark forest standoff. From civilizations that vanish into digital dreams to ones that never leave their ocean cradle, we've walked through a gallery of possibilities, each one a window into a different kind of cosmos. These 25 scientific solutions aren't a list of answers, they're a spectrum, a map of all the ways reality could be structured to explain the silence. And every point on that map challenges our human logic in a different way. Some possibilities are a comfort. They suggest we're precious or protected or simply early. Others are a warning. They paint the void as a place of hidden dangers or inevitable ends. But all of them, every single one, accomplish something. They force our perspective to widen. They pry our gaze from our own reflection and make us stare into the true, vast, often incomprehensible depths of what might be. The greatest lesson from this journey might not be which solution is correct. It might be that the paradox itself is the gift. A cosmic riddle with no single solution is the ultimate catalyst. It fuels humility by reminding us how little we know. It sparks creativity by demanding we imagine realities beyond our own. And above all, it reignites a pure, childlike wonder. The simple, staggering wonder that we are here at all, in a universe so strange and silent, asking these questions. If this exploration has shifted how you see the night sky, even a little, we'd love to hear from you. Which of these 25 possibilities resonates most with you? Share your favorite solution in the comments below. For more journeys into the mysteries of space, be sure to subscribe. And as you look up at the stars tonight, remember this. The search for an answer, the courage to ask where is everybody in the face of an endless quiet, that act itself might be the truest signature of intelligence we will ever find.